So here's my fuselage project. Firstly, I did a different design. I used circular cross sections with long beams connecting the circular cross sections. I did this because when I looked up images, it's what the commercial airlines used. This animation kind of shows it better. Now, mine's a simplification. There's no windows or doors, which makes mine more simple than what it would be in real life. Some properties of my fuselage to begin with before you see it is that the weight is 381 pounds, which is over the expected, which is supposed to be 300 pounds. I could have fixed this by changing the length. I just ran out of time, and I know this is late, so you want it now. Again, my length is 20 feet, which could be shortened to account for the weight to make it the right weight. The important fact or statistic to take from these material lists that was the same in both of my reports is that the yield strength is 40 ksi and that I use titanium. So here you can see I have 3 circular cross sections with long straight beams like this, and then there's also diagonal beams to add triangulation to add strength to my fuselage. So my forces include force due to gravity, a 500-pound force on each side for the wings, a 750 and a 750 across the back 2 pipes to simulate fuel and baggage, and then a 300 and a 300. This 300 is the co-pilot and pilot. This 300 is the engine, which would mount on this surface right here. As you can see, the max deflection is 15, almost 16 inches, which obviously is unacceptable. It happens right here. So it shows that my fuselage fails in the first loading scenario. These constraints are floating, pinned. I did that because when on most landing crafts I see, or fuselages I see, there's 3 tires that I see at least, and one which I perceive to be the back one is a brake, and that's why this is a pinned, because it resists both upward and translational motion, while these are only floating because they only resist upwards because there's no brake applied on them. Also, I flattened the bottom of my fuselage so that landing gear could be attached. As you can see, the KSIs here, which this one is pretty ridiculous, so it's over 1,000, all are greater than 40, which is why my displacement is so great. In the second scenario, it was a little bit better. I had 12 inches here instead of 15. The only difference in my force is that now I use 15 Gs, and then my constraints are fixed. They're fixed because the wing does not move. Also, my wing is attached between the 2 circular cross sections. Again, the reason why my deflection is 12 inches is because these forces are all greater than the strength yield, which was 40 ksi. Possible improvements, since my fuselage did fail like it did, would be adding more circular cross sections. This would significantly add the strength, because before, when I couldn't get the program to realize that there were cross sections, my displacement was like 150 inches, and now when I added only 3 cross sections, it reduced to 15. So obviously, by using more cross sections, my strength yield would be increased significantly. And then also turning the bottom cross pattern, this thing right here, into more of a triangulation pattern would help with strength. Force distribution could also be improved. That can always be manipulated to have a more ideal situation.